describe how you would investigate the variation of the extension of the spring when different loads are applied. Mention two precautions you would take to obtain accurate results. For accuracy, label each axis of the graph with the name of the quantity, its symbols followed by and by the unit. Proportionality holds because the limit of proportionality will lead to the load extension graph to non-linear region. So we increase the load and we see that for corresponding load the extension is same. If at some stage we increase the load force and the extension is more than the proportionality band, so it is approaching its limit of proportionality and where it moves to the non-linear region. So we should be very conscious at that stage limit, so that we can operate the spring within a linear region. So part B, a table below shows the result obtained in an experiment to study the stretching of its spring. Copy the table and fill in the missing values. What can you say about the relationship between the extension of the spring and the stretching force? So in the first move we have this 200 and 0, so 20 and 0, so next 20.2, so this 100 grams or stretching force is 1 Newton, so the extension is 0.2 with 200 grams or 2 Newtons we have 20.4, so the 0.4 is obtained in the 320.6 or 0.6 extension extension is obtained, so in 420.8 or 0.8 extension is obtained with this 521. So extension and stretching force is proportional. The limit of proportionality of the spring is not exceeded. It is shown from this graph that spring is working in a linear region and the proportionality limit of proportionality is not exceeded. And the spring in figure 1.538 stretches from 10 centimeter to 22 centimeter when a force of 4 Newton is applied. Calculate the spring constant of the spring. So this is 22 centimeter minus 10 centimeter, so the extension is 12 centimeter, so the 4 Newton is applied, so K is equal to F upon X, so 4 Newton divided by 12 centimeter, so it is 4 divided by 0.12 meter, so this is 33.33 Newton meter. So this is the spring constant. In the extension is proportional to the stretching force when a force of 6 Newton is applied. Calculate the new extension length of the spring. So this 6 Newton is equal to K is equal to 33.33 Newton meter and X is equal to F upon K. So F is equal to 6 Newton and 33.33 Newton meter, and by dividing this we have 0.18 meters, that is 18 centimeter. So the final length will be, because the initial length was 10 centimeter, so the next level is 28 centimeters. 4 Newton applied to the stretch string from 10 centimeter to 22 centimeter. Now 6 Newton is applied to stretch the spring further from 10 to 28 centimeter. And now two forces of 5 Newton and 12 Newton act at a point. The two forces first act in opposite direction. Make a sketch showing the direction of the forces. This is 5 Newton and this is 12 Newton, so the net force in this direction is 7 Newton. Resultant force so this is the resultant force, and the two forces act at an angle of 90 degrees to each other. Calculate the magnitude and direction of the resultant force by calculation. So this is 12 Newton, this is 5 Newton, and here we have this 2 Newton can be written down as 1 centimeter is graphically represented. It can be represented graphically, and it can also be written down like this Pythagoras theorem. So F resultant would be the F1 square, and Ft square, then 5 square plus 12 square, so it is 13 Newton, and this is 12 force and this is 5, so the tangent of this 12 divided by 5 is equal to 67.4, so this angle is 67.4, so this is making this much angle from the north side, or this from the x-axis it is producing from this 5 Newton force, it's making an angle of 67.4 degree. So it can be written down like this. The direction of the resultant force is shown in figure, and starting from the rest on a level ground, a girl can reach a speed of 5 meters per second in 10 seconds on her bicycle. Calculate the acceleration. So initially the velocity was 0 and her velocity, final velocity, is 5 meters per second after 10 seconds. So the acceleration is obtained as v minus u upon t. So this 5 meters per second, this initially it was in rest, so 0, so in 10 seconds divided by this, so acceleration is 0.5 meters per second. Calculate the average speed during the 10 seconds. So average speed is u plus v divided by 2, so this is 0 plus 5 meters per second divided by 2 is 2.5 meters per second is the average speed. Calculate the distance she traveled in 10 seconds. So the distance traveled in 10 seconds is equal to s equal to ut plus half at square. So initial velocity was 0, so this is 0 plus half at, acceleration is 0.5 and time is 10 square. So this is 0.5 into 100 is 50 divided by 2 is 25 meters. Eventually, even though she still pedal as fast as she can, she stops accelerating and her speed reaches a maximum value. Explain in terms of force acting why this happens. The drag friction forces increases as the speed of the object increases. So act to produce acceleration and slow the object down. This is one of the reasons friction force is playing a role. Even though she still pedal as fast as she can, she stops accelerating and her speed reaches a maximum value. Explain in terms of force acting why this happens. This happens because of this friction force or drag force. Explain the following using F is equal to ma. A car has a powerful engine and made it of a strong but lightweight material. So F is equal to ma. M is small. So if m is small, acceleration will be high. A is high for powerful engines. So therefore F is equal to ma. A is proportional to F. If F force increases, acceleration increases. Mass increases, acceleration decreases. A car with a small engine can still accelerate rapidly. With a high force, more acceleration will produce for fixed mass. So for fixed mass, a acceleration with high force, more acceleration can be produced. A rocket has a mass of 500 kilogram. Calculate the weight of the rocket on Earth when g is equal to 9.8 newtons per kilogram. So weight is equal to mg, w is equal to mg. So 500 kilogram into 9.8 newton per kilogram. So this is 4900 newtons. At it lifts, the rocket engine exerts an upward force for 25,000 newton. Calculate the resultant force on the rocket. Calculate the initial acceleration of the rocket. So lift up force is upward force, that is 25,000 newton. The resultant force is upward force minus downward force. So downward force is 4900. This is 4900 newton. This is the weight of the object, the rocket. So this is the difference between this is 20,000 and 100 newton. So this 20,100 newton divided by mass gives the acceleration, that is 40.2 meters per second square. So this is also very, very important. Initial acceleration. And a car round a bend travels in an arc of circle. What provides the force to keep the car travel in a circle? Velocity has both size, magnitude and direction. Speed has only size or magnitude. Velocity is a speed in a stated direction, and if the direction of the moving body changes, even if its speed does not, then its velocity has changed. A change of velocity is an acceleration, and so during its rolling motion, the ball is accelerating, followed by that Newton's first law of motion, that if we consider a body moving in a circle to be accelerating, then there must be a centripetal force acting on it to cause the acceleration. So this arc in a circle is due to the centripetal force, because the direction is changing. So direction is changing, acceleration is there. So if acceleration is there, the force is there. Force is there, that force is a centripetal force, because the acceleration is there, because the direction is changing, so acceleration is there. When a car rounds a bend, a frictional force is exerted inward by the road on the car's tire. Is a larger or a smaller force required if the car travels faster? Car travel faster, it means accelerating. Large or more force will be required. More force will be required. A bend or less curved, bend is less curved. A small force will be required because A is smaller. A car has more passenger. More passenger with more mass, so acceleration will be lower. In order to keep car moving, more force will be required so that acceleration can be increased. Explain why racing cars are fitted with tires called slicks, which has no tread patterns for dry tracks and with tread tires for wet track. Slicks, no tread patterns for dry track and tread tires for wet tracks. No tread pattern for dry track to reduce friction. So it reduces. If there's no tracks, no tread patterns, means no obey track to reduce friction. So friction will be less, because the friction increases as the speed of the object increases. The friction increases as the speed of the object increases. But for a racing car, we want to have lower friction. The tread patterns for wet tracks to increase friction to avoid skidding. So tread patterns are always used in a wet track so that skidding could be avoided. So figure 1.5 shows 3 position of the pedal on a bicycle which has a crank of 0.20 meter long. The cyclist exerts the same vertically downward push of 25 Newton and with his foot calculate the turning effect in. So here we are applying this force. So this force, here we are applying this force, here applying force. For the first force, since the angle is 0 with this crank, so there is no net work done. So the turning effect will be 0. Because this sine angle is 0, and in the part B we have this sine angle is 45 degree. So this sine degree is 45 degree, 25 newtons and 0.2 and 45 degree. So this gives 8.84 newton. For the part C, we have this force, and this crank distance is 0.2 meter. So this 0.2 meter into 90 degrees, so 12.5 newton meter. The more force turning effect will be high in C, and no turning effect in A, and middle level turning effect in B. In question number 9, we will discuss in the